you survived to the last video, or maybe this is just the first video where you looked at the homework problems and you said, Jason, what the heck is going on here? Well, hopefully I can answer you. We're getting into the start of applications. This class has a ton of applications, okay? So if you hate applications, hopefully I can change your mind, all right? There will be a lot of them. And this is where they begin. Pretty much every section is going to have applications. As far as your quizzes and your exams go, I'm going to be trying to split them between theory and applications so that we get a good mix of both. Okay, so here we go. We are on example 6, and this is where the typing really does start to become bigger. So example 6 is, let C of x denote the total cost in dollars. Oh, it's doing the funny thing again, huh? In dollars of manufacturing X units per day of something. All right. Then we're going to ask a couple questions about this and see what happens if I can figure out how to use this software. All right, so there's going to be a couple parts to this, and we are going to, I didn't write the formula down in my notes. So let's just say the formula is C of x is equal to, say, 5x plus 1,000. All right. So we have a couple questions here for you. First question is, what is the total cost of producing 10 units per day? So again, you just look at the original problem. We have information, mathematical information, C of x. This function shows the total cost, C, of manufacturing X units per day. So here, right, our X, that's just 10. We just plug that in, okay? What is the cost when X is 10? We just plug it in, and that's going to be 5 times 10 plus 1,000. You can do that on a calculator. This will be 50. 50 plus 1,000 is 1,050. So our answer is going to be a cost of $1,050. And you'll notice something here, right? We have this 1,000 that's sitting here. This 1,000 is really big, right? This 1,000 is most of our final answer. This 1,000 is what's known as fixed cost, okay? The 1,000 right here is the fixed cost. And this corresponds to business expenses that have nothing to do with how much you're producing. Okay, so maybe it's the rent for your facility. Maybe it's the salary of your employees, provided that you don't use more or less fewer employees to produce variable amounts. So for small domains, for small domain ranges, that could make sense. Maybe it's your insurance, maybe it's your heating, maybe it's whatever. It's the stuff that you always got to pay, whether or not you're producing anything. Okay, that's called fixed cost. And likewise, we have this 5 up here, right? Where this is the thing that gets bigger or smaller depending on how much you're producing. We say that 5 right here is what's known as the marginal cost. And marginal cost is just the cost of producing an extra item at that point. So for lines, this 5 is just going to be the cost for producing an item. But for more complicated modeling functions, more complicated production capabilities and models, marginal cost is going to get marginally more confusing. Okay, so we'll talk more about this in greater depth later on. Okay, so again, there's a lot of stuff in this where we may not go into super in-depth definitions, but you can find them. You can ask me about them. You know, We live in the age of internet, as you can see, because you're watching this video from the internet. Okay, so let's go on to the next one and do part B. All right. Part B says, what is the marginal cost? So I already answered that, but so a lot of times we're going to associate marginal cost with two things in this class. A lot of times marginal cost has to do with slope or derivatives, which we haven't talked about yet. And really, this is the same thing because a derivative, which we haven't gotten to yet, is essentially just a slope. Okay, so in this problem, right, we have, this is our equation. So the slope of this equation is the 5x. Well, the slope is the 5, right? So the slope is 5, marginal cost is $5. The y-intercept, 1,000, that's the fixed cost, okay? So slope and y-intercept is just marginal cost, fixed cost, okay? So again, we already answered this before. Marginal cost is $5 per unit. Last part for this example is, what is the cost? Here, we'll type this one out. It's a little longer. Is what is the additional cost of raising daily production? Daily production from 10 to 11 units. Now, there's two ways to answer this question. So this right here, by the way, this is the definition of marginal cost, right? The additional cost, right? This just means the marginal cost when producing 10 units. Marginal cost is the additional cost. What's that extra cost of one more unit at this point? Okay? And so we already know from part B that the answer for marginal cost should be $5. Did I scroll somehow? Oh man. That's interesting. So we already know what the answer should be. Okay? The answer should be $5. Let's find out. We could do it a different way, right? See, the additional cost of raising production from 10 to 11, we could also just do, well, what is C of 11 minus C of 10? You plug it into our original formula, which, right, was this 5x plus 1,000. Plug in 11, plug in 10, subtract them, and see if we actually get $5. Okay? So that'll be 5 times 11 plus 1,000 minus, be very careful to include parentheses here. We have to subtract all of C of 10. Okay? Minus 5 times 10 plus 1,000. And that's not going to fit. You type this in onto a calculator. Well, again, you can also see it, right? The 1,000 up here, we have plus 1,000, minus 1,000. Those are going to cancel. What are we left with? 5 times 11 is 55, minus 5 times 10, which is 50. Of course, we get $5, which is what we expected. The additional cost of raising daily production from 10 to 11 units. Why? It's $5, which is exactly what we thought was going to happen. Okay? And that's example 6. 2 more examples, again, optional, depending on whether you want to see them or if you can do all of these problems on your own. Feel free to get working on the homework. Let's do the next 2, though. All right. So, example 7. The owner of a gas station can sell 1,500 gallons per day at a cost of $2.10 per gallon. and they can sell 1,250 gallons per day at a cost of $2.25 per gallon. So if this is linear, find g of x, gallons sold per day, at a cost of x dollars per gallon. All right. So we need to find the line. Okay. This says linear. Linear means we're looking for the equation of a line. So notice that g of x, right, this is kind of like our y value. And x is kind of like, well, x is obviously our x value, okay? So what is the x value? X right here is the cost per gallon. All right, cost per gallon. And y, or g of x, is the gallons sold that day. So let's just find our x values and our y values. So notice it can sell 1,500. All right, is 1,500 our y or our x? Well, it's 1,500 gallons per day. So right here, this is a y value at a cost of $2.10 per gallon. Okay, that's going to be the corresponding x value. So we already have a point, right? We already have the point. X is 2.10 or 2.1, and y is 1,500. That is 1 point on this line. And we know we're looking for a line because it says linear right here. And linear just means line. And now we do the same thing with the other pair right here. Okay? Well, when it's 2.25, then they can sell 1,250. And I just want to pause real quick. Notice, if we charge more, look at these points down here. If we charge more, we sell less gas. This makes sense. This is one of the fundamental things of economics, right? The more expensive something is, the lower the demand. People are going to buy less of it. Okay? So that's what's happening here. So things are working like we expect them to. We have 2 points. We need a line. Go back to the video 1. We need to find the slope, and then we'll use point slope form. Okay? So we need the slope. Remember that m is rise over run. So you can subtract, let's say we'll subtract the bottom ones from the top ones. So the bottom y is 1,250. The top y is 1,500. The bottom x is 2.25. The top x is 2.1. You simplify that out, and you're going to get negative 250 on the top. And the bottom is going to be 0.15. I do not know how to do that in my head. So let's see, it's negative 250 over 0.15 is approximately, we will be approximating in this class. And again, I'm going a little bit off. My apologies. This will get better over time, I promise. Approximately negative 1666 repeating. All right. You know, in kindergarten or whatever, we learn how to stay within the lines. Well, maybe I need to go to teacher kindergarten and stay within the frame for the video. All right, so that's our slope. All right, so we have our slope and we have a point. You can choose either point you want. Let's choose that point, okay? 2.1 and 1,500. So we have our point, 2.1, 1,500. We have our slope, m is equal to negative 1666.67. Technically, it's not equal. It's approximately equal to, so we're going to use these little wavy lines. And now we use point slope form. Y minus the y coordinate, which is 1500, is equal to m, which is negative 1667.67. Oh, 66.67 times x minus x1, which is 2.1. And you might say, all right, we did video 1. This is the equation of a line. We're done. But remember that this problem is being a little bit more specific, right? This problem says find g of x. We need to find the whole function here. And g of x, remember, is y. The g of x is y. We need to solve for y in this case because we need our answer as a function. So let's add 1500 to both sides. And we're going to get, let's not use red. We're going to get that y is equal to negative 1666.67 times x minus 2.1, just like before. And then we're adding 1500 to both sides. So there's a plus 1500. And this is the final answer. It's not fully simplified. If you really want to simplify it, that would be best. So let's simplify it and express it in terms of g of x like it wanted. We're going to get g of x. If we distribute this, we're going to get negative 1666.67x, and then minus that other term, and then plus 1500, and we have a very beautiful little flurry of snow just started outside. I'm getting very excited about that. The negative 1666.67 times negative 2.1 plus 1500, that's approximately 5,000. Okay? So this is the equation. Relating, remember, x is the cost, it's the price, and g of x is how many gallons we can sell. So again, the slope is negative. That makes sense. As we increase x, right, we have a negative slope. As the cost increases, since the slope is negative, the gallons will decrease. Okay? The more we charge, the fewer people are going to buy it. All right? Now, be very careful not to confuse these two examples. Okay? Because in the previous example, whoa, I just added a bunch of extra pages. In example 6, right, we said, oh, the slope, that's the marginal cost. The 1,000, that's the fixed cost. That's only for a cost function. So don't go all gung-ho on me. This is not a cost function. This is a relationship between supply and demand. So this is no longer marginal cost because this is not a cost function. This is no longer the fixed cost because it's not a cost function. So your slope and your y-intercept means something a little different here. Be very careful about that because it's probably going to show up on next week's quiz. All right. And it will pop up in the homework as well. In fact, that's the last example we have for you today. Example 8, we're going to talk a little bit about that. So we had a nice little segue into there. Okay. So example 8. Oh no. This is a process. This is a process. So example 8 says, it says I need to be over here. Oh dear. Oh no, everything is falling apart. My apologies. Example 8. The demand equation for a manufacturer is the following, and I'll leave a little blank there, where X is the number of units produced and Y is the price. Interpret the slope and y-intercept. So again, if this were a cost function, the slope would be the marginal cost. The y-intercept would be the fixed cost. But because what we have right here is a demand equation, not a cost equation, it's a little different. Here, let me actually give you the equation. Y is equal to negative 0.02 x plus 7, comma. Okay, so again, there's no marginal cost here. Marginal cost has no meaning unless you're actually talking about a cost function. Okay, this is the demand equation. Okay, so demand equation, not cost. So let's look at what a demand equation means. Again, we're going to be dealing with demand equations all semester long. Okay, so let's start with it now. X is the number of units produced. So if we produce this many units, then we can sell at cost Y. Okay, sorry. It's less about kind of phrase in a sort of confusing way. Number of units produced. Let's say we have, like, we sort of have this implicit assumption that we want to sell all of them. Okay, so if we want to sell all of them, we're going to have to sell them for a lower cost, right? If we only want to sell, if we don't want to sell as many, we can charge higher. This also makes sense, right? If I've got, you know, if I only want to sell one car, no, that's a terrible example. Not gonna improvise today, but if you want to produce, if you flood the market, this is better. If you flood the market, right, the cost is going to go down. But if there's very few items, the cost of those things is going to increase. And that's what's talking about here. Let's start with the y-intercept over here. So remember, one of your basic things about math is that y-intercept is when x is equal to 0. So our y-intercept is the point when x is 0 and y is 7, because the y-intercept is 7 here, right? So x, right? Units produced, units we want to sell. Okay. 7's the price. So if we don't want to sell anything, we can charge $7. Or let's flip that. If we charge $7, nobody's buying nothing. All right. I don't know what we're selling, but if we charge $7 for this thing, nobody's buying. Okay. That's what this means. We will sell 0 of these things if we charge $7. Okay. So at a price of $7, we sell nothing. But notice what happens. As we increase, right, x is 0, is it? Price is $7. But as we increase the number of things we want to sell, the price is going to decrease. As x gets bigger, y gets smaller because we have a negative slope. Okay? So what is our slope, right? We say interpret the slope, but we don't know the slope. The slope, right, is negative 0.02. We always talk about slope as rise over run. But this isn't a fraction. Let's make it a fraction, right? That's negative 2 over 100. That's negative 1 over 50. And rise, all right, m is equal to negative 1 over 50. That's the rise, that's the y. That's the run, that's the x. So, hold on. I have the solution for all of you. I have the solution for all of you because I keep blocking everything. We're going to have Ghost Jason today. Okay, Ghost Jason for the rest of the video. And now you can see what I'm writing behind me. All right, we found the solution. So notice, right? As we go down 1, we go right 50. That's what the slope means. What does down 1 mean here? Down 1 is y lowers. Okay, so down 1, right 50. Y is the cost, the price. So if we lower the price by 1, x increases by 50. We can sell 50 more. And this is probably the hardest question of the entire section, all the videos. Okay, so please watch out for this. So I actually used 2 different colors, but here's our answer for the y-intercept. Here's our answer for what the slope means. So there's a lot of layers to this. You're gonna have to do extra problems. You're gonna have to think it out. You're gonna have to ask questions. If you have someone else that you know in this class, that's great. Talk about it with them too, as well as me. If you don't know anyone else in this class, this is the perfect time to get to meet them. All right. So watch out for these. Do the homework assignments. There's only one homework assignment this week, and please ask questions. I know there's really long videos, but I wanted to make sure to give you guys as many example problems as I could. All right. So hopefully you enjoyed it. All right. Maybe you didn't enjoy it, but hopefully it wasn't super painful and you learned something. But yeah, seriously, ask me questions. This stuff is not easy, and it's quite frankly not ever going to get any easier after this either. So we're in it for the long haul. We're in it together. Please ask me questions. This is an online class, but it's not like you're just watching a YouTube video, right? Like, I'm actually your instructor. Okay. We can actually have dialogue. I'm recording these videos just the week before we do them. So it's all updated. It's not like you're just listening to guys speak from 50 years ago or whatever. So be invested, participate, ask questions, and good luck. Bye-bye.